All right, guys, welcome to this page of the notes, and hey, let's go ahead and do another half-life problem because these things are great. So here's what I've got. I tell you the half-life of plutonium-239, that's the isotope of plutonium, is 24,000 years. Determine the value of K, the decay constant, for the equation representing the half-life of this radioactive isotope. Well, I know it's decay, and they asked me to find K, so I'm going to need to use A, e to the minus kT. And here we go. Plug in what I know. We are doing half-life. The half-life is 24,000 years. I didn't give you an initial and a final amount. That's because you don't need one. Pick your own numbers as long as the initial and final amount are half of each other. So I like 50 and 100 because 100 is an easy number to work with, and 50 is half of it. 24,000. All right, here we go. I divide 100 to the other side. Surprise, surprise, you get 1/2. Just like in the problem we did before, I have a base e. I need to get the k, is my variable I'm trying to solve for, but it's in the exponent position. I need to get it out of the exponent. So since I have a base e, we'll just take the ln of both sides. We do ln. Because ln, every calculator has a natural logarithm button on it. It's that important. Every calculator gets one. And I know that ln and e are going to cancel each other out. It's a thing of beauty. So e and ln cancel each other out. I'm left with just the exponent. ln of 1/2 is equal to negative 24,000 k. I get the k by itself by dividing the negative 24,000 to the other side. Here we go. Throw all of that into your calculator. Don't fat finger something on your calculator. You should wind up with 2.88 times 10 to the negative 5th. Which as a decimal is going to be 0.0000288. Either way, scientific notation or as a decimal, you guys, Algebra 2, you should be comfortable going back and forth between the two. Remember, if you have to move the decimal point to the right, it'll be a negative exponent. If you have to move the decimal point to the left, then it'll be a positive exponent. But anyways, that's all scientific notation stuff that you guys have gone over in probably every science class since middle school. So anyway, there we go. That's how we find the half-life of plutonium. Well, actually not find the half-life. We find the decay constant, in this case, for plutonium-239. All right, head on over to the next page of the notes and we'll try a couple more problems. I'll see you guys there.